All right, so we are going to talk about some Python, specifically doing object-oriented stuff with Python. Uh, I'm just going to start off with, I have the class attributes and methods lab here to start with, and probably want to talk about the relationship stuff a little bit as well. But we will have plenty of time to talk about that when we do code challenge stuff. So, as usual, before we get started, is there anything that you've hit up to today, even anything that you've hit in Python that, or I guess let's stick with last week because the stuff we did today is not going to be on Code Challenge. So anything up through the stuff we did last week that you want to talk more about, you need to dig into more, it's just not clicking.
Um, I would say stuff like inheritance and decorators, and then
Mm.
also properties.
Yeah, okay. What else?
It finally started clicking, I think, like today, but like the difference between the different kinds of methods and attributes, right? Class attributes, instance attributes, methods. Like I think it's clicking with it's almost like there's so many vocabulary terms that they're getting lost to me a little bit in there.
Mhm.
So
Yeah.
I don't know, touching on that might help a little bit.
Yeah, and a lot of that is object-oriented programming has so much jargon around it. Even if you've like we've done object-oriented stuff in JavaScript, we just didn't call it that, right? All the all the methods and stuff on arrays and build their own things. But yeah, there's a lot of words that already mean things in English that mean things differently in programming. So yeah. Um, anything in particular that feels a little bit wonky to you in that regard?
Not really. It's more of just like it it feels complex because of
Yeah.
how many different, like I said, vocabulary terms there are. I think I've got it. I think I understand it, but if you ask me right now to define like an like an instance method versus or a static method versus a class method, I know class method says at class method before it, so that one I've got, but the other ones I might have trouble. I'm not. And
Yeah.
like where would you like use those individual things?
Yeah.
So
So yeah, let's just talk about that a little bit first before we jump into some code. So let me start from the larger part and zoom in. And please stop me if you have any questions about the terminology or concepts or anything's even a little bit fuzzy, because this is stuff that you'll be using forever from now on. So let's start with a class. So a class is just a specification of a certain kind of thing. A vehicle could be a class, and that includes, cars, trains, planes, hovercraft, spaceships. A car could be a class that inherits from vehicle, and that would include every kind of car, and have methods and things that work with those kinds of objects. So inside a class, there are, I don't want to say two scopes, because the confusing thing, especially in most of these languages that you're going to be using, unless you go to like Java or something, classes are either basically or very closely analogous to functions that give you these other objects, right? Um, so, and a class is just a thing. Like it's not a there are some languages that have, like, it is built into um, the sort of bones of the language, but a class is just a thing, just an object. And so when you let's first talk about the class methods, I guess. So actually, so you have a class that is your factory for making things. And when you say, give me a new one of these things, this new dog or car or whatever, that is an instance of the class, right? That is an object that belongs, or that is in that class, which is a weird way of saying it. It's hard to conceptualize because it takes attributes from the class that generated it, but it's not like a part of it, unless, which is going to be confusing because the stuff we're going to be working with, they are actually a part of the class, kind of. So we have our object, which is the actual thing, and we have the class, which is the description of the thing. Class is cars, object is my 2009 Toyota Matrix. So this is the concrete thing, this is the idea of a thing. So, and this gives us two places to hang properties and methods off of. We have the things that you're going to be using most of the time are instance methods and properties, which are things that are attached to that specific version of, or that specific instance of that class. So I can say, this car color, red, this car mileage, way too much, whatever it is. And then you can operate on the instances on that class. So drive, fill the gas tank, change the oil, sell the CarMax, whatever you want to do there. Really need to get a new car. So those are on the instances of the method. And similarly, since the class again is just a thing, that can also have methods and properties. So a property of the class might say, like, how many objects have you created since we started here? It could be what are some useful things on a class? My mind is totally blanking on what for class properties you might have. Yeah, I'm sure there are some, and they'll come to mind. But again, more often I think we'll be using class methods, and these are methods that act on the entire class, which may or may not include the object that creates. So, if I have a class of what's a good method? I mean, new, right? Creating a new thing. That is basically a class method, or that's the constructor, the initializer that's creating it. I could say, return me, and again, I'm just going to use examples. I'm trying to use examples that are not things that we're going to be doing, but we're going to be doing these things. So you can say, hey, class, give me a list of all the objects it's created, and it can return at that. Or, hey, class, do this method that alters something else, or turns it into this object, or does something with a collection of objects. So you can almost think of, no, that's not true. You kind of, sometimes depending on the class, you can kind of think of class methods as kind of like a library of functions that has to do with the class. But often it'll, especially in the cases that we're doing with object ORMs, they'll have to do with the collection of things. So disregard that. But yeah, so does that make a little bit more sense? You have your concrete things and your idea of a thing, and you're going to have classes and properties on both of those, but they're separate. Or did that just confuse things more? Cool. And we'll do a little bit of code that shows off some of that. And yeah, an object is just a chunk of data with some handy functions attached to it that we call methods that operate just on that data mostly. And the reason and this is kind of why, so in JavaScript, an object-oriented language, if you have an array and you want to sort the array, you would create a new array, and that's the array object. And you say array.sort. That's the method on the object that will give you a new array. In Python, which is less object-oriented, a person coming from another language like JavaScript or Ruby or whatever would think, oh, I have an array or a list of stuff. I would like to sort that. So I would call array.sort, right? Nope. There's just or map, we'll say. There's a map function that you pass the array to. So that's kind of inside out from the way we want to think about object orientation, which kind of makes it difficult to think about object orientation in Python sometimes because your brain has to switch between these two modalities. That being said, the object-oriented stuff in Python is fine. It's good. It lacks some features like private methods and private properties and stuff that most other object-oriented languages have. But there are conventions that you can use to kind of work around that a little bit. Yeah, and then inheritance. I guess like we were saying, we have a class that's an idea of a thing, a person, and we can have another class. So a person has number of eyes, blood pressure, job, we'll say. Yeah, there we go. So we can make a person that has those things. We can also have like a mailman class that inherits a bunch of stuff from person. So we can automatically set, a new mailman has a job automatically set as mailman. And ideally you wouldn't be able to change that because then it would no longer be a mailman. But it'll also inherit methods from the parent class. So if person has eat, walk, have a stroke, the mailman also has those methods without having to rewrite them in the child class. And there might be a bunch of child classes. Child, president, dock worker, whatever. So we don't want to have to rewrite all of those things for each one of those subclasses, which also might have subclasses and so on. So being able to grab those methods from the parent is super cool. Yeah, I think that's it. Anything I made less clear or more clear? Any more talking about that stuff we want to do before jumping into making with the typing?
I did have a question, just like if you could go through like some debugging methods, because I have kind of completely ignored the IPDB thing and just like been relying heavily on the tests, but the tests are also incredibly annoying. So it feels like there should be a better way to know if I'm doing the right thing.
Yeah.
Yeah.
And again, this is a matter of taste. Debuggers are good for some people. Other people like myself, I usually just like put console logs or print statements in there. And so I know, oh, when I'm running this, the value of this is this, or, oh, it's not getting to this part of the code at all. So there are some things that are easier in a debugger, some things that are easier in the logging methods. I honestly couldn't tell you which ones are easier in a debugger because I don't believe that. But yeah, it's a matter of choice, whichever way you do. So we can.
Yeah,
we
I don't love the
that too.
debugger method. I don't love it. So I feel like if you could show some ways of like how to do things in the shell, because I feel like I've just been ignoring that and then I don't know what's going on. Cool.
Yeah. I would love to talk about decorators, but let's do this first. I'll save like the last 5 minutes or so for decorators because they're super confusing and very cool. So any other questions or any talking you want to do before we open up some code?
You said that in Python they don't have private methods or I guess if you could just go into, I think I know what the conventions are, like the underscores or things like that, but if you could go into kind of more, you said there are ways to work around it.
Yeah, I mean that's pretty much it. There are so all the things on all the objects are open to the entirety of the code base. That's not great. Not because we're worried about someone maliciously changing our code, because if they have the code, they can change stuff whenever they want. The reason we want private methods and stuff is for encapsulation, one of the foundational things of object-oriented programming. Encapsulation means that like building an API or whatever, or using an API, we build this interface around the object and we define these things can go in, these things can come out. Here's some methods. Otherwise, what's inside should not matter at all to the people using it outside. And private methods let us do that. So we can call a public method that does some whatever magic with whatever's inside with private methods, and then get our result. The problem with not having actual private methods is that someone could, take this class and say, oh, this is cool. I wish it did this a little bit differently inside. Maybe I think it's more efficient because I think I'm a better programmer, but I'm probably not. So I'll like go in and like change one of the methods inside, or I'll, stick another property on there because it doesn't provide something that I want. And I'm like, oh, I would like to keep, the color of this thing. So I'm just going to add a dot color to it. Or change the way it's representing stuff inside, which, if it works, again, rule one, if it works, it works. The problem comes when the good programmer that did that finds another job and someone else has to maintain their code and they only know about the public interface of that object, and that object stops behaving the way that you expect it to. Or if, someone, the developer of that object decides they've found an actual better way to do the internals and they change some of the stuff inside, they change some of the private methods, then anything that relies on that from the outside is going to break immediately. So generally sticking to the published interface, the public methods, public properties is going to do you good. But Python does let you go in. And so using convention is fraught because there are several conventions. I think the one we do here is putting an underscore before it or 2 underscores. And that's, doing that is mostly a note to yourself or whoever else is going to be working on that code with you that, hey, this is something that we don't talk about outside of this class. This is just, this is a janky counter variable or flag that I use inside because we need to use it. Someone else outside could change it, but if you do that, like double underscore or something in front of it, then they know the thing that I'm changing or using might break later on. But yeah, like anything else, since no one outside the class should be using it, whatever convention makes sense to you, rule 2, is the best way to do it. So, I like putting 1 underscore underneath. Some people like putting 2, some people like surrounding with underscores. And the same with constants. Like constants are important. they like prevent a lot of bugs from happening. And Python does not have constants, but they have the convention of all caps, but that doesn't help at all. So that's another thing. Does that answer what you were asking? Awesome. Yeah, I'm doing my best not to talk shit about Python, but it's so hard. It's fine. It's fine. I know a lot of people who like Python and use it all the time. Awesome. What other questions do we have or anything we want to talk about? Cool. Let's go ahead and I will share my screen. And let's look at some code. Let's bring up the chat there. Move everyone around there. Hide the controls there. Great. So this is the class attribute lab. Chat over here. Great. Class and attributes and methods lab. So basically, we're just going to be building a class with some methods and things inside. I think this is not fully baked because it talks about constants, which it does not, and talks about exceptions, which it does not. And it says, I think, does it use static at all in here? Only in the notes. Yeah, so static is just another word for a class method. It comes from other programming languages. Cool. So we want to take a look at what we're going to be doing here. So we're going to create this song class, and it's going to be in here, which has nothing in it. Great. We're going to create the song class that has some things in it. It's going to have the let's see, each. Okay, so our first one is going to be a class or static property, it looks like, and that's just going to be a number. And you can tell it's a class method because we're referring to the class, which is capital S. Another, so this is going to be a class property, I guess. And again, the wacky thing about Python here is that if you just wanted to go and say change the song count, you can do that. It's not great. But we're going to do it, and we're going to add a list of artists and a list of genres. And this lab is a little weird. It's going to keep a list of the genres and the artists. It's not going to keep a list of all the songs for some reason. We can change that. Great. So here's our instructions. We're going to define a song class over here, such that an individual song is initialized with, so it takes the 3 properties there. Then we can test that by looking at them. And this is where we'll kind of do the debugging stuff. So let's just do those parts first. So we've got our class here. How do we, what do I want to ask first? How do we set up a constructor for the class? So we can pass it some stuff and create a new instance. First of all, what is a constructor or an initializer?
The init method.
Yeah. And this is the function that runs when we create a new one. It creates a new instance and then does some stuff to it. So what does that look like?
Diff,
Mhm.
def, and then underscore, a double underscore init.
Yep, there we go there. Oh, hey, look at that. Cool. So this takes a bunch of properties. The first of which is always going to be self, and self refers to the thing that's calling this function. So the instance is going to be calling this function on itself. So what else did we want to take here? We wanted to take a title, an artist, and a genre. So I'll just call that title, artist, and genre. And we don't need to worry about that. Cool. So we have these things, and we want to, we're not doing anything with those things yet. So how do we attach properties to an object when we initialize it? Jason.
Sorry, I missed that one. There were some distractions in here.
How do we when we take arguments in the constructor, how do we attach these to properties on the class?
It'd be like self dot title equals title, self dot artist equals artist, self dot genre equals genre.
Exactly. Artist. And again, self is a reference to the object itself. It's being called on. So that's letting us attach stuff and set up stuff to that object. Cool. And so here's where I would do some testy stuff. I might want to make sure I'm getting what I'm expecting. So I can run code down here if I want to use print. Nope. Here's some debugging. I don't need that anymore. So if I want to run this, lib, great. I should just be able to do Python song py. Great. So it's defining the class, doing nothing with it, and then I'm just printing out, hey, we got this far. So I'm gonna create a new song here. So what's a song? Give me a song.
I have a slightly
Oh, yeah.
unrelated question, but in
Yeah, go
the
for it.
this is just on Python in general. The quotation marks and single quotes, so to speak.
Mhm.
Is there like a method similar to JavaScript where you could, like, I just had it come up where I put single quotes at the beginning and end of that, and it made it obviously interfered. Is there anything like?
Yeah, you can just escape.
Okay, all right, that's all I was wondering.
Yeah, and just make sure I'm not lying. There goes. Yeah.
A song name. Hang on, let me open Spotify. I'll get one.
Yeah, for some reason I have to think of a song completely empty.
Let's put it Disco Descent.
Okay, just go.
And what were the other things we needed?
So we're creating a new song. So it's song. So we need to give the title, which is Disco Descent. Who's the artist on that?
Danny Baranowski, Baranowsky.
KY.
Yeah.
And what what kind of song is that?
I would call it techno, I guess.
Cool. Perfect.
It's video game music, but that's
Excellent. Electronic.
Yeah.
Cool. So we know nothing broke when we made a new song. So let's just print out some stuff. I'm just gonna print out the Disco Descent title, and I'll print out the artist and genre here. And see. Great. So we created an object. We have some properties here. Let's say I didn't do it right. So let's see without these. So the first one I'm going to just print, make sure it works. Hey, it looks like it works. Great. So now I'm going to debug out all three of these lines. How about let's undo. So now I'm going to print out those things like I did before. And I have a hint here that that's not a thing because it's a different color. But if great. So now it's giving me an error. It's telling you where the error is and say, oh, song has no attribute genre. I'm pretty sure there is. I typed, oh no, it's just Jen here. I mistyped it. So that's one thing I do. Like if once I'm familiar with a language, the basics here, I probably won't do that. But if I get an error, I certainly will. In fact, I would probably first say, print title, artist, genre here, just to make sure I'm getting it inside. Great. And in fact, I'd probably say like print, init, parameters, so that I know, and I'd say song init, so that I know where those are coming from if it's a more complex thing. And then once I saw that I got all those in, I'd be like, okay, cool. What did I do wrong? And I eventually find out that it was that just by doing some printing along. So those are basic instance properties. Any questions there? Cool. Okay, so now we have to create a class attribute count. And so this count is going to keep track of the number of songs that are created in the song class. And this is going to be a class attribute. So how do we set a class attribute in here? Or where would we put that?
Before the initialization?
Yeah. So again, different languages do it different ways. We can just say it was count, right? Count equals 0. So when I put this in the class itself, not inside of a method or in the initializer, that's what's telling it it's part of the class, not part of an instance. Sweet. So now we just want to increment it whenever we create a song. So where would we do that? Or actually, let's make sure that this is working. I'm just gonna, excuse me. I'm just gonna print song count, and I'm expecting 0. What? Great. So I know that that works. So where would I want to add the incrementer when to keep that count correct?
In it?
Yeah, so we want
Uh-huh.
to increase that when we are creating one, and here's where we're creating one. So I'm going to put it at the bottom, just in case something bombs out. I don't want the count to go up before the thing is there. So we'll just say count plus plus. Does Python have plus plus? I don't think it does. How would I find out? That way. Python, why you gotta be so 2004? Does it have plus equals? I think it does, right? Yeah, okay. It's a little bit civilized. Nope. That reference before assignment.
Self.count?
Yes. So if I do self.count, what is that going to refer to?
Oh, that would refer to the instance, right?
Yeah. Can I refer to the song class here? How would I do that? If I can at all.
To be class.count,
Um,
or would you have to do a class method?
Like
and
that?
then-
yeah.
Yeah.
Yeah, so we could write a method, and let's look at that in just a second. One of the things I would try as a programmer in general would be to try and do that. Since song is a thing, we should be able to reference it there and see if we can just increment it there. Does that work? Hey, it does. Great. So one way to, and I genuinely did not know if that was going to work or not. One way of accessing class variables is just by saying class dot the thing, and that works inside or outside of the class. If I wanted to break encapsulation some more and say song count, oh, I've created a song, so I want it to be 23 or whatever. This is why we can't have nice things. Ideally, you should not be able to do that, but here we are. So upshot is you can both read and write to class attributes by just saying class dot the attribute, and that's inside or outside of the class. Yeah, so the other thing you mentioned was writing a method to do that. Yeah, interesting. So let's go ahead and add a new method here. So we defined init just like a function inside the class. So let's increment count. And that's going to take self. We don't need to give it any other attributes because it's just going to increase by 1. I could call it self here, but just to make it clear, is that what we want to do? Yeah. I want to talk about decorators, but I'm not going to do it right here yet. To make it a class method, like someone said before, decorators. Decorators are just functions that decorators are just higher order functions that take the function below it as a callback. We'll talk about that for 5 minutes at the end. In about 10 minutes. So here, since we have defined a class method, the thing that's being passed in is not self, it is the class. And I don't use the word class because that is a reserved word in Python. But now we can say CLS, and that is referring to the class song. And we can just say, hey, count plus equals 1. And then we would call it here. And since this is a class method, yeah. I don't, does Python like to do this? I'm going to try something. I actually don't know if it's going to work or not. Oh, it does. let's see if this works. So we are incrementing the count by calling it. And in fact, if we want to debug it, we can say, in increment count. So now we know that function is being called. And in fact, if we want to be extra debuggy about it, what if I wasn't sure if this was working or not, I would say, print CLS count, and then do it before and after. So, so that way, when that function runs, printing that I'm in the function, I'm printing the value before I change anything. I'm printing the value after I change something. And then we're printing the count at the end. So let's see if that does what I want it to do. It does. What is it? I don't like that. So I'm not going to go into detail why I don't like that, but it's the thing you can do now. So self in there refers to the class method. And self refers to the object in other cases. That feels bad. I just want to test something out real fast. If I make another method that's not a class method, they'll and this is going to be an instance method, so it's going to take the self there, right? It's just going to take self, and I'm just going to print and then here I'm just going to call it. So I'm just expecting to at the end have it cry out in anguish. And it does. So inside the function, inside the class, you can call self refers to the object, but the object has access to class methods. That's a confusing part for sure. Yeah. We'll talk about that a little bit more. But for now, know that that works. So self increment count is the way we're going to increment count there. We have debugged before and after, so we know that it works, and our debugging at the end tells us also that it works. Great. And usually when I'm debugging this way, instead of commenting out those debugging lines, I'll just delete them altogether, unless it's something that I need to turn off and on a lot, just to keep everything sort of uncluttered. Cool. So we did that. Oh, hey, look at that. Says it right there. Cool. I'm just going to do this part for genres. I'll do it for artists first, or I'll do it for genres. So we want to keep track of all the genres of all the songs. Why we're not keeping track of the songs, I don't know. It's not in the spec. So we're going to create a genres class attribute that's going to be an array or a list. And I'm going to do it up here. And so this is a class. And I guess the important thing also to remember about class methods and attributes, but more attributes, is that they persist no matter what you do to the objects themselves. So I can create 100 objects, delete them, create a whole bunch more, and so on. And those, unless we're explicitly doing stuff, those won't affect class things, but we are explicitly changing them here. Yeah, so I'm just going to add the genre to our list. A list. Again, this lab reads kind of weird to me, because it's asking us to keep a list of genres. And we are going to be adding it. And let's just do it. So they want us to add a new genre every time we create one. And so let's write another method just to keep that a little bit clean. It's gonna be another class method. And that's our decorator. So we have let's say def add genre. Yeah, that's fine. And again, we're gonna have our class here, and we're gonna need our genre. So we'll just call it genre. And so how would we add the genre that is passed in to our genres class parameter here, class attribute?
CLS dot genre
Yeah.
genres dot append genre.
Python doesn't have push, does it? Append genre. And so I'm going to talk for a second about why this is weird to me. So it only wants, so whenever a new song is created, we're going to add the genre to the list. All genres are going to be added to the list. Control for duplicates when you code your add to genres class. Not when you add genres to the original genres list. So this is asking us to only add the genre to the list if it's not there already. So we won't have duplicates. And I'll probably do this with just well, look at the class. I'll do if and it's exists in if it's in, yeah, so if it's if a genre is not in, then we do that. So basically it's checking to see that. So I can add the song a bunch of times and then print. And it should only give me techno once or nothing. What do we do?
You need to call it in the init.
I need to call it in the init. That'll do it. Yep. And I need to call with the genre here. This is why debugging like this is great. Great. So, and if we didn't have this line, we'd have techno. But we do. So, and everything else is basically like this. I just want to talk a little bit about why this is a little bit weird. If you want a list of unique things, and they have to be unique when they add it, just use an object or a dictionary or a map or whatever they like to call them, because the keys are unique, so you don't have to say if it's there, and that way it can double as a count. So I would probably do this by keeping the genres, because we're also going to want the count. So I would probably make that a object like that, and then have the keys. When I add techno, it's going to have the count there, and so that gives me for free. I can I can write a genres method that gives me just the keys of that, and I can get a genres count method that gives me the full thing that I already have there. But cool. I'm not going to code that out. That's just an exercise for the reader. Yeah. I don't want to step through the whole thing, because it's basically just like this over and over again. So yeah, any questions about stuff we've done here? Has this been useful / interesting? A little bit. Cool. I want to talk about decorators for a second, because it's really cool. So again, decorators are not specific to object art stuff. They can be they're just functions. And let me remember if I know how to do this right. So I can say, my decorator is going to be, what's going to be, add, add lines, we'll say. So this is going to be a function, and it's going to take a function in as an argument. So let's call it fn. And basically, I want to, we'll just do prints here. I'm going to print out a line, and I'm going to print out what the function does. I'm going to print out another line. So I'll just say print. Great. Duplicate that. And then I'm going to print the result of calling function. So this is a function is a first class object, so we can pass it in just like any other callback. It's just a thing, right? So if we write another function here, def say my name. Let's say print hi, I'm name, like that. That's how we do that in Python, right? Yeah, that looks all right. And so let's just call say my name here. Mark, and do it with great. So if I run this, and we're not using our add lines here yet, if I did everything right, it should just say, hi, I don't need the $sign. Hi, I'm this name. Hi, I'm that name. So what I can do here is, so if I want to call it with just like we would normally, I can say add lines and then just say my name. I think you can pass in the arguments. Let me see if that works. Nope. How do you do this? We're gonna look it up real quick. Yeah, I think that's what I want to do. Yeah. I'm just gonna do it. I'm not gonna worry about that part right now. Cool. I'm just gonna say my name like that. Cool. So I don't need to pass it. I'm Mark. Mark. And it's not taking your name. Cool. Okay, so simplify. Right now, it says, let me do it without this so it's easier. Great. That's just doing say my name. And this is just, and it's printing out the return value. It's printing it. Oh, I just want to call a function. I don't want to print it out. There. So now it's printing whatever the first function prints with lines around it. And I'm just calling that function by passing it there. Now I should be able to, unless I did something wrong, which is entirely possible. So this is just a decorator here. And I think, is that going to work? It's not going to work. What did I do wrong here? It's a function. What's the error here? You just don't like it at all? No particular error? What's the error? Invalid syntax. Line 12. Okay, let me try it with that. I think that's also going to bomb out. Yeah. I don't know what I did wrong. I don't have to do a colon here, do I? Nope. Maybe? No.
I think it needs to go above the definition, not above the call. So add lines above def, say my name.
So what I want to do is take this decorator and
Mhm.
add it to this function. In my brain, this is how it works, but I don't think it is. I will do some research. But and it works differently in different languages. Maybe I'm thinking of JavaScript. But yeah, so basically, just to know, decorators are just functions that do something with the function that you do below it. I know there's an easy way to do this. I can't remember what it is now. I don't want to keep it too long while I futz around. Cool. Yeah, I'll look this up more and talk more about it some other time. But other than that, we're at an hour. You don't need to sit and watch me do that for that long. Yeah. Any questions, lingering questions, or thoughts about object-oriented stuff so far?
How much can you tell us about the code challenge?
I can tell you a lot about
I was gonna ask a more, I might as well just ask what I'm actually thinking.
Yeah. So we're gonna do a mock challenge. We'll probably do another one. We'll do one tomorrow and Wednesday. And that will be basically exactly what's gonna be on it. There's probably gonna be, and I don't know specifically which one, but I think they're all structured the same. There's basically gonna be 3 classes. And I don't think there's any inheritance on it, but I'm not 100% sure. But basically 3 classes that are going to have relationships. So you might have, and this may be, may very well be exactly what it is, but you might have a, let's say you're, let me abstract it a little bit. You're a, there's musicians, there's venues, and there's gigs. So you can create musician objects, you can create gig or venue objects, and then you would create the gig object, by taking an instance of those classes, and then you'd have a bunch of those that have, you can call different things on. So it'll be creating a couple classes, 3 classes, writing some methods on them, and hooking them up that way. Or it could be like, doctor patient appointment. I think there should be labs in there that are similar to that. If not, there should be. Yeah, but we'll definitely go over basically exactly the challenge, minus the specific methods that we put on Tuesday, Wednesday.
Awesome.
Yeah. Cool. Yeah. And that'll kind of map onto the stuff we'll be doing later for the ORMs. Awesome. I'm gonna stop sharing here for a second. Thanks for hanging out with me up to this point. Anything else you want to ask before we close up shop here? Yeah, you bet. I just discovered today who your lecturer will be for next phase. Let me actually stop recording.